The next point in rotational dynamics is angular momentum and linear momentum. Linear momentum is mass into velocity and the angular momentum is, yes, mass convert into I and velocity convert into angular velocity, that is I into omega. Let's prove it. So we know that L bar is nothing but the R bar cross P bar, that is a P bar is a linear velocity, mass into velocity, and R bar is a positions vector. So the velocity is nothing but R omega, so we will put the linear momentum mass into velocity instead of velocity R into omega. So angular momentum is nothing but mass into R square into omega. Similar way, calculate L1, L2, L3 up to Ln. So total L is equal to mass into R square into omega. Omega is common, take it outside from the bracket and the remaining terms become I. So angular momentum is nothing but the moment of inertia I into omega. And in terms of the linear motion, its momentum is equal to mass into velocity. So mass convert into I, velocity convert into angular velocity. Now the next question is, derive the torque equations in terms of moment of inertia. It's a 3 marks questions. Simple, don't do rectification, just say what is the equation? Torque. What is the formula of torque? Force into displacement. Yes, force into displacement. What is the equation of force? Mass into accelerations. Okay. And what is the equation of acceleration? R into omega. Go with the reverse way. So we will put these all values in terms of force. So it become mass into R and this R get R square into alpha. So it's simply m R square alpha. Similar way, calculate torque 1, torque 2 and torque 3. So it become, again alpha is a common, take it outside, angular acceleration. Torque is equal to I alpha, which is analogous to the in linear motion, that is torque, force become torque, m become I and acceleration become angular acceleration. Somehow say that the angular momentum always conservation, that is conserve in nature. So conserve means it's a constant, throughout process it's a constant. If there is unbalanced force, external unbalanced force is there or not, then it should be constant. Conserve means it should be store or jatan karne. We know that linear momentum of an isolated system is conserved in absence of external unbalanced force. Let's calculate, that is we have to prove that L bar is a constant. The term constant means their derivation should be 0. So we will take differentiate that L bar is equal to R bar cross P bar. That is differentiate with respect to time t. So dl by dt is equal to, use u into v rule, R keep it as its constant, differentiate with respect to p, so it becomes dp by dt plus dr by dt cross p bar take as it is. So we know that velocity is nothing but distance upon time. So dr by dt is nothing but the velocity. Okay. And dp by dt is nothing but the, yes, Newton's law, that is the force is nothing but change in momentum. So we will put that value r bar cross f bar plus v bar cross p bar. Now R bar cross F bar keep it as it is. V bar cross P bar means mass into velocity, but cross product of same quantity is 0. So dl bar dt is nothing but R bar cross F bar. But initially we know that force into displacement means torque. So dl by dt is equal to torque. Now if there is an unbalanced force or external absence of unbalanced force, then torque, force is 0, torque is 0, then dl by dt is also 0. Hence means angular momentum is conserved. That is dl by dt is 0 means L bar is constant. Now what is the applications? Have you seen the ballet dance? Ballet dance, the moment of hands is, its moment of hands is when it's move away, the speed get increase, when it goes to it get decrease. Similar way, it moving of positions of hands, the ballet dance will be, it will be rotate in his one leg. Okay, so what will happen? If the r is get large, then moment of inertia get large. Okay, because moment of inertia value is depend on m into r square. If the radius get large, then consider this is the center of mass. If radius get large, then I get large. But with the formula of L bar is I into omega, and we know that L bar is a conserve, means constant. If the I get increase, then for matching that L bar, omega means speed get decrease. Hence, R get increase, speed get decrease. And when R get decreases, speed get increase. So that's why the hand movements get move, and it's depend on their speeds. If their radius increases or distance of hand through the center of mass, then it will be speed gate decreases, and if the hand's movements is closer, then speed gate increases. Similar way, second applications is diving in swimming pool. During the competitions, it takes more and more turns at some heights. That is, it will be move. If the radius is small, then the speed gate decreases, and that's why it will be move. Hope you enjoy these lectures. Thank you.